In this video we're going to look at finding the inverse of a matrix and ultimately finding determinants of matrix. Determinants are very important and the inverse is very important, and we might see in some later applications with vectors and with solving simultaneous equations, how we can do them through matrices. But first we need to know how to find the inverse and how to find the determinant. Now we're going to look specifically at finding the inverse of 2 by 2 matrix, okay, because we can get, sorry, there's a problem with the pen there, we can get instances where we need to find determinants of and inverses of a 3 by 3 matrix, which is a different method. So this here we're looking at a 2 by 2 matrix. Okay, so we're going to do it in general terms first, and then we might do an example if we have time. So if we state that A, or matrix A, and it's a 2 by 2, so we're going to have A, B, C, and D, then the determinant of this here, which we can find by, we can write determinant of A equals, and the determinant of A, what we do here is the determinant is we multiply AD, so AD we subtract by BC. So what we're doing is we're multiplying along the main diagonal and we're subtracting the other diagonal. Okay, so the determinant. Another way to write the determinant is you can draw it with a triangle, but the triangle's got to have a little bit coloured in here, and we get the determinant of A, again, AD minus BC. Okay, so that's the determinant. Another way the question could be presented is find, we use straight brackets, A, B, C, D. That's also the same as finding the determinant of A. So again, that will equal AD minus BC. So the product along the main diagonal subtracting the other diagonal. So there are all the kind of representations we could have of the determinant. Now, if we want to take that a step further and we want to find the inverse, so we want to find the inverse of A to the minus 1, we need to find the determinant and then we need to change it up a little bit. So the inverse is going to equal 1 divided by the determinant of A, and then we're going to have our matrix, but we're going to rearrange it ever so slightly. So what we do is we swap the main diagonal, the elements of the main diagonal, and then we change the sign of the other diagonal. And that's what our inverse will be, which ultimately will equal 1 over AD minus BC, DB minus C and A. So that's it all in general terms. We'll look at an example in a minute. But to get an inverse, we need to find this determinant first. So the determinant of A, the det of A, is AD minus BC. So the product of the main diagonal subtracting the product of the other diagonal. It can also be represented in this way, or it can be done with straight line brackets. We find that. To get the inverse is 1 divided by the determinant of A multiplied by this matrix that we've changed ever so slightly. So what we've done is we've swapped the entries along the main diagonal, and then we've changed, we've changed the sign, of the other two entries, okay? So along the main diagonal you swap them, other diagonal you've changed their entries, the signs of their entries. Okay, so hopefully that lets you know how we go about finding the inverse and the determinants. It allows us to do our division, and that can be very useful down the line. So we're going to look at an example of that in the next video because we're out of time in this one.